In this demo, I'm going to get you familiar with iNotify_data_error_info, which is an asynchronous version of iData_error_info. So starting point here is the end of the last demo where we implemented iData_error_info. I'm going to drop into my customer here, and I'm going to implement iNotify_data_error_info instead of iData_error_info. So I change my interface to iNotify_data_error_info. I will use Visual Studio to stub it out. And then I'll go down to the bottom here and I'm going to comment out the iData_error_info methods since they're not going to be used anymore. And let's look at the API of iNotify_data_error_info. First off, it's got an errors changed event. And I'm going to use the delegate trick here to make it so I don't have to check for nulls, which was discussed earlier in the course. It's got a getErrors method that's going to be queried by the binding when you hook up to it. That's the logical equivalent of the indexer on iData_error_info. So it's going to be passed in a property name, but notice this one returns an IEnumerable. So one difference here is that the indexer for iData_error_info only allows you to return a single error string per property. With iNotify_data_error_info, they recognize that you could have more than one rule associated with a given property, so you can return a collection of errors. And then there's a hasErrors property that's first going to be inspected by the binding before it calls getErrors. So the basic sequence of events is if you have a binding that you indicate that you want to use iNotify_data_error_info, and you hook it up to an object that implements that, when it goes to set a property, it's going to check and call the hasErrors property. If that returns true, then it's going to call getErrors. If at some point after it's called getErrors, the errors changed event fires, it will come back in and call getErrors again, assuming that there was some asynchronous process that went out and determined errors, populated the collection of errors behind the scenes that getErrors is using to return its values. So basically, to start fleshing this out, what you need is somewhere to store some errors. And this shape of that is generally going to be a dictionary of string, comma list of string. So you want to have that collection of errors that you return up here for a given property name, where the key is the property name. For the implementation of getErrors, we can just simply reach into that property errors collection, see if there is a key for the property name, and if so, return whatever the value is, the list of strings associated with it. Now I put a lock statement here because we're going to go and do some asynchronous work using a separate thread. And that separate thread needs to be able to push errors into this property errors collection. So if you're going to do that in a multi-threaded way, you want to make sure you protect that dictionary because it's not thread safe. Or you could use one of the concurrent collections that are available in the .NET framework. I'm just going to use a basic dictionary here and lock on it. Next, we need to implement this hasErrors method. So I'm going to flesh that out by calling a method, again, because I don't like putting complex logic in a get block personally. And what this method really does is it just loops through all the keys in the dictionary, checks whether the underlying value is null, and if there are any non-null entries in the dictionary, then it says that there are errors present. And it's going to return true to say there are errors. And then the binding will come and call getErrors for the property it's bound to, and it will look up the errors and see if there are any. So that's a simple brute force implementation of iNotify_data_error_info, but now we need to trigger errors to happen somewhere. Now the whole point of this interface is to support asynchronous scenarios, places where you're going to go and set a property, but you need to go do something like a service call to invoke some logic on a back end to decide whether the value that was set is valid or not. And something like a service call takes a long time, and you shouldn't be blocking the UI waiting for it. So you want to go out and do that asynchronously. Now for demo purposes here, I'm not going to set up a service and call it. I'm just going to use a task-based method to simulate this. So this method is using the task parallel library. It's defining a method called getErrorsForPhone, where I can pass in a value. And what it's going to return ultimately is a list of strings, but it does it through a task that can be invoked asynchronously. So inside of this in a real thing would be the point where I would dispatch an asynchronous service call. But instead what I'm doing for demo purposes is I'm just going to use tasks.factory.startNew, which causes it to dispatch whatever's inside of this action delegate on a separate thread. First thing I'm going to do is go sleep for 5 seconds so that you can see when I run this that it's truly happening asynchronously. Then I'm going to evaluate the logic that presumably is back behind a service call or something that's going to take a long time to compute. And ultimately, I'm returning my list of strings, or a null if there are no errors. So basically, I want this to be invoked at a point where I know that a phone value has changed. So naturally, a good place for that would be in the set block of our property. So I can go up in here, and after the property has been set, I can dispatch some asynchronous work. So I'm going to call that task-based method, which is non-blocking because it's asynchronous. And when it is complete, I use a continue with, this is part of the task parallel library, and say what I want to do when it's done is basically go push any errors that came back in into that property errors collection. But because this is all being done async, this is going to happen on a separate thread. So this is where I need to also do locking on that dictionary before I try to modify it, so that only one thread at a time can be messing with it. So I basically just take the result property of the task that comes back in from our continue with. That will be the list of strings that came out of my task. And I can push that into the appropriate dictionary entry based on the property that I'm setting. Once I know I've modified that collection, I need to raise that errors changed event associated with the iNotifyDataErrorInfo and tell it what property has changed. That's going to trigger the binding that is tied to that property to go ahead and requery getErrors. So with all that in place, I can go ahead and run. We can go into the cell phone entry here, put in an invalid value, tab out of the field, count to about 5, and we should see a red box appear. Boom. So that was that 5-second delay with the thread sleep, went out, evaluated the rule, returned the list of strings, raised the event, and triggered a getErrors, and the errors had been placed into the errors collection in that asynchronous handling. Now you can see if you implement it this way, getErrors can certainly still execute synchronously. All it's doing here is returning whatever is already in the errors collection. So if we're able to synchronously invoke a validation rule client-side up here from the set block of the property and populate the property errors then, those errors will show up automatically as soon as getErrors gets called. Those errors will be returned automatically when this gets called, which happens after the property change fires from the set block. Now notice that our demo worked even though we have validates on data errors true here. There's a separate property for validates on notify data errors if you only want to support iNotifyDataErrorInfo, but validate on data errors will also pick up iNotifyDataErrorInfo.